In the previous tutorial, we created the targets that define our lateral. Now we're going to use those exact same targets and create multiple well plans and compare how the different planning methods approach the same lateral. So let's get started. First, we'll enter in our username and password, click login. Next, we're going to go to well actions, click on manage workspace, expand all, and for this example, we're going to use plan 1 and duplicates plan 1. We're going to call it plan number 2, and we're going to create plan. We'll click open, and this will bring up a duplicate plan of the plan that we created in tutorial number 1. Next, we'll go to targets, and you can see here that the bottom hole location, midpoint, and our first take point that we created in tutorial number 2 are still in place for this well. We'll delete this plan that we made in tutorial number 1 and start off with the S well planner to create our plan number 2. We're going to assume the surface casing is like 1600 feet. We're going to do dogleg build and drop of 1.5 degrees and a hold angle of 20 degrees with the final ink of 0. We'll use our first take point for our target, and we'll click calculate. Now, since we use the S well planner with our final inclination at 0, that means we're going to hit our first take point vertically. Next, we'll go to Dogleg Toolface. We'll select curve hold. We're going to build our curve on 10 degrees per 100, and we're going to aim for the midpoint target that we created in tutorial number 2. Now, once we hit calculate, that'll build a trajectory to midpoint number 2. Now we want to aim for the bottom hole location, but we're going to do it on 2 degrees per 100 now. So once we hit calculate, that'll define the trajectory, hitting the targets that we built in tutorial number 2. We'll go to 3D view, and we can see how this wellbore looks in 3D space. So even though us as well planners are happy with the wellbore trajectory, our reservoir engineer comes and says he doesn't want to hit the first take point vertically. He wants to be in the lateral by the time we hit that first take point. So to suit his needs, we're going to create another plan, and we'll call it plan number 3. So we'll create this new plan, and we're going to go to the hold option because we know we need to set our surface casing vertically at 1650 feet. So we'll click 1650 feet for TBD. And then next, we're going to go to Optimum Align. We're going to build our nudge on 1.5 degrees per 100, and we're going to build our curve on 10 degrees per 100. The target we're going to hit will be the first take point, and the target we're going to aim for once we hit the first take point will be the midpoint. So we'll calculate, and then we're going to go back to hold. And since Optimum Align already has our final trajectory aimed at the midpoint, we just got to go back to hold, click vertical section, and click calculate using the midpoint as our target, and that'll hit the target that we created in tutorial number 2. Next, we'll go back to Dogleg Toolface. Since we're already at the midpoint target, we're going to select bottom hole location target, use a 2 degree per 100 dogleg severity, and click calculate. Now this new trajectory has us hitting our first take point in the lateral. We could compare it to the old trajectory that we just built by going to offsets, selecting plan number 2, hitting the checkbox, and applying that offset. We'll go back to 3D view. We'll select show offsets, and that'll show both plans that we put together and the differences between the plans in the 3D view. So now reservoir is happy, drilling is happy. However, our production engineer isn't happy because he says he wants at least 2,000 feet of vertical before we drill our curve. Now that doesn't work with our current plan because now we're holding 9.88 degrees as we enter our kickoff point before we build our curve. So what we're going to do is we're going to take note. We're going to see that the inclination is 88.9 at the base of the curve, and our azimuth is 179.68 at the base of the curve. We could use these numbers to help us calculate a new kickoff point that we can hit vertically and still hit all of our targets that we created in the earlier tutorials. So we create a new plan. We'll call it plan number 4. We'll go to the curve planner option, and we'll type in an inclination of 88.9, an azimuth of 179.68, and we're going to build our curve on 10 degrees per 100. Now the goal here is to plan a new kickoff point that has the same displacement as this curve does on 10 degrees per 100. So we're going to look at our TVD, we're going to look at our northing, and we're going to look at our easting, and we see that the difference in TVD is 572 feet, the difference in easting is 3.1 feet, and the difference in northing is negative 561.9 feet. So we'll go to targets, and we're going to create a new target named kickoff point. So the target name will be KOP, the description will be kickoff point, and we're going to define this target by offset. And the way we're going to do this is we're going to look at our first take point, and we're going to subtract the curve displacement from that first take point. So the first take point northing was negative 145.1. We're going to add 561.9 feet to that. The easting was negative 1362.7. We're going to subtract 3.1 feet from that. And the TVD was 10,250. So we're going to subtract 572.9 feet from that. Now, what we've done is created a new kickoff point target using the first take point as a reference and subtracting the curve displacement that we got when we built our curve on 10 degrees per 100 earlier. So we'll go back to our S-well planner. We'll use the same inputs that we had before, with the exception of instead of defining a hold angle, we're going to define a final hold length because we know our production engineer wanted that 2,000 feet of vertical before we hit kickoff point. So we hit calculate. That defines a new S-roll trajectory where we're at vertical by kickoff point. We're going to do Dogleg Toolface, and we're going to do to a point. Now, this first point that we're going to aim for will be the first take point. We'll hit calculate, and this is going to line us up facing the midpoint. So now we'll go back to hold. We'll do vertical section. We'll select midpoint as a target, and then we'll hit calculate. Now our trajectory is at the midpoint. So we're going to go back to Dogleg Toolface, and we're going to build on 2 degrees per 100 until we hit the bottom hole location using the curve hold option. So we'll select curve hold, 2 degrees per 100, select the bottom hole location, and we'll click calculate. Now we'll go back to our 3D view and see how this looks in 3D space compared to plan number 2 that we put together earlier. If we want to compare it to plan number 3, we'll go back to offsets. We'll hit the plus button and the example well selected offsets until we get to plan number 3. We'll delete the other plans that we pulled up because we're only trying to compare plan number 2 and plan number 3. We'll apply the offsets. We'll go back to 3D view. And now we can see all 3 plans that we put together where they're all hitting the first take point and all hitting the same bottom hole location. However, how they got to these targets is slightly different, with one hitting the target vertically, one hitting the kickoff point at an inclination, and one hitting the kickoff point being straight vertical. We can also go to section view and see the wellbore trajectories in this view. If you want to change your vertical section azimuth, you go to vertical section azimuth that's on the main screen. You'll select the azimuth that you want to view it at. In this case, I'm changing it to 180, and that'll change the azimuth that you're viewing your vertical section graphs at. Now we can go to center to see how these wells compare against each other. And you'll notice at 10,750 feet, as well as the bottom hole location, that all 3 designs converge on each other because all 3 designs use the same first take point and bottom hole location. Separation factor is no different because all 3 designs use the same first take point and bottom hole location, so your safety factor at both of those points will be 0. On all these tutorials so far, we've only looked at anti-collision using the same well but different designs. In the next tutorial, we'll add an offset well and examine how different tool codes, magnetic models, and well trajectories affect anti-collision results. We'll then adjust the design to maintain a safe separation factor and reduce collision risk throughout the well path.